Hello everyone and good afternoon. Very good afternoon. So let's wait for another 1 minute so that everyone can join, and after that we can start with the classes. So yes, for some 30 seconds or 40, 50 seconds, let's wait for others to join. So Janvi Vizag is here. Hello, how are you? How is everyone? I miss you people, really. I was expecting classes in the weekdays, but it couldn't happen for some reason. So I hope आप लोग भी क्लास मिस कर रहे होगे. I don't know. Just some more 30 seconds. After that, I will start. Okay. I know it takes time for you people to walk from your houses to classes, but still, if time is fixed now, 3 o'clock, please, please, please do me a favor, like try joining classes on time. Because already we are having only how much time? Only 50 minutes now. Even if we are not utilizing this 50 minutes, what's going to happen? Class 12th student you people are, and this is a huge responsibility then. So we need kind of time also to complete everything properly. है ना? सिर्फ syllabus खत्म करना तो नहीं है ना, खत्म होना चाहिए आपकी तरफ से. You should also feel like yes, syllabus is finished, I know something, and now I can just solve question from all the topics that I have been taught. So for that, now I need time, right? So everyone, please try joining on time. It's very much important. ये आदत होती है बच्चों की, like after lunch we feel lazy, but being a student you should not feel lazy. तो चलो मैं start करती हूँ. Still only one JNB I can see here. Let's go ahead. So what we studied in the previous class, just a quick recap of previous class. So method of charging we discussed, and the very first method that I discussed was charging by friction. Done. So in charging by friction, what we do, we rub two objects, and during that process, what happens? Electron transfer happens. One gains electron, other loses. Done. But by this method, we can only charge insulator. I have explained the reason properly, because a conductor won't sustain the charge. It will simply transfer its charge to some other conducting bodies like Earth. So this method is used to charge only insulator. ये key point था इस topic का. ठीक है? Now charging by conduction, what we do in charging by conduction? In charging by conduction, we have a conductor. This is charged conductor. We have another conductor. This is uncharged, neutral. We bring them in contact. During contact, what happens? It transfers some of its charge to it, and this body gets charged. Again, this method is used to charge what kind of material? Conducting material. Okay? This is very important. During this method, contact is required. During this method, one body loses its charge, and another body getting charged attain the nature of charge of the first body. जो first body के पास जैसे nature of charge है, same nature of charge will be taken away by the second body. ठीक है? तो ये था हमारा conduction. Now what was there in the induction? In induction there was no contact. What we did, we were having a insulator, charged insulator, and it was brought closer to a conducting body. This was neutral. And what was happening? This positive charge, since this is a conductor, it has free charges, positive and negative. So negative charge will get attracted towards this, positive charge will get attracted towards this. We were earthing it then. है ना, अर्थ से कनेक्ट कर रहे थे. अर्थ will take all these charges, not this charge because it is bonded by this. Done. And after that, what we were doing, we were first removing the earthing, and after that we were removing this to the infinite separation. ठीक है, तो कुछ ऐसा हो रहा था. And in induction, no contact required, है ना, no contact required. This body is not going to lose any charge, and this neutral body is going to get charged negatively. Okay, so opposite to this. Then, so we extensively discussed all such things. No deep discussion we need now. And last thing that I discussed was Coulomb's law. Coulomb's law was about what? If we have 2 point charges, remember this is only true for the point charges. So if we have 2 point charges separated by separation r, what will be the forces between these 2 charges? So force between these 2 charges will be K Q1 Q2 by R square. Done. So some more people joined. JNB Simoga. Why you people are so late here? Why so much late? This is online class now. 50-minute time is there. We can't go beyond that time. Huh? If you're coming late, you're losing time, right? So you should come on time. Please do this favor upon me. बच्चों की आदत होती है लेट आना, बट दिस वोंट वर्क यार. मैं वहां हूं नहीं, अदरवाइज आई वुड हैव मेड इट श्योर, बट आई कांट. तो यहाँ से मैं रिक्वेस्ट ही कर सकती हूँ. प्लीज, दिस इज अ वेरी हम्बल रिक्वेस्ट. प्लीज पुट अटेंशन टू इट. ओके, चलो. तो यहाँ पे what the thing is, this is k, and k is what? K is equal to 1/4 pi epsilon naught. Its value, if I have not given before, so its value is 9 into 10 to the power 9. ठीक है, with proper units. Okay, epsilon naught was what? This was permittivity. I have discussed what the permittivity is. So this is permittivity of vacuum here, and its value is how much? 8.85 into 10 to the power minus 12 with proper units, right? So this is the value of permittivity. What was the permittivity? It decides how much one charge can see another charge in a particular media. In short, it decides what will be the amount of force acting between these 2 charges. I said in the previous class, permittivity of vacuum is least, and that is why in vacuum, force acting is the maximum. Because vacuum means, I use a metaphor here, and that was your fog, है ना? तो अगर fog नहीं है, means it is vacuum. And if there is no fog, these 2 charges can see each other very clearly. And in that case, what will happen? Force acting will be maximum. अगर 2 इंसान एक दूसरे को अच्छे से देख पा रहा है तो जान पाएगा, है ना, और interact कर पाएगा. Similar thing is happening here. So force acting in the vacuum will be maximum. So these things I discussed in the previous class. Also, I discussed the vectorial form of Coulomb's law. So that was nothing, just a extension of whatever we have studied it, or just a repetition of whatever we have studied it. तो यहाँ पे मैंने एक Q1 charge रखा था, and here there was a Q2 charge. This was at some distance R1, this was at some distance R2. And if we have to write force between these 2 particles, I am talking about force. So it has both magnitude and direction, है ना? Magnitude भी है और क्या है? Direction भी है ना? So just give me 1 minute. JNV Rajkot. Why you people are so much late? Please maintain this decorum. This is also a class. Online class doesn't mean ना कि आपने बटन दबाया फिर वहीं से वो start हो रहा है ना? Yes, you can see the recorded lecture, but still live class has different significance. You can interact with me, you can ask questions. So it's very important you join on the time. When you don't join on time, what happens now? I am also forced to start late, and that should not happen. Okay, चलो, तो किसी को भी late नहीं आना है. This is my motto. If का क्या है? Magnitude लिखना है and direction. So if I'm talking about force acting here on charge Q2, so on charge Q2 I am calculating force. So force acting on second because of 1. Q1 will apply force on it. Both are positive charge, so Q1 will repel Q2. Repulsion means Q1 will apply force on Q2 in such a way that it will push Q2 away from itself, yani ki in this direction. Then, so this is the direction of force. What is the magnitude? This distance is how much? R21 vectorially. I have proved earlier also. So let me simply write it K Q1 Q2 by R21 का मॉड्यूलस का स्क्वायर into direction क्या होगा? Unit vector in the direction of R21 vector. That is this. R21 is nothing but R2 minus R1. This is nothing but vector R2 minus vector R1. So this is nothing but the distance between these two points. Okay? Vectorially we have written it like this. Now in today's class, so Coulomb's law we are already done with. Permittivity we have already discussed. So in today's class we are going to discuss principle of superposition. ठीक है? तो यहाँ हम लोग क्या पढ़ने वाले हैं? प्रिंसिपल ऑफ सुपरपोजिशन. तो चलो अगेन ये कुछ भी नहीं है, सिंपल है, जस्ट हम लोग वेक्टर को पढ़ने जा रहे हैं, नथिंग एल्स. ठीक है, तो यहाँ पे देखो व्हाट आई हैव डन. सो सुपरपोजिशन प्रिंसिपल व्हाट एग्जैक्टली टेल्स इज कि अगर हमारे स्पेस में इफ देयर आर मोर देन टू चार्जेस, सपोज you have Q1 charge here, you have Q2 charge here, and you have Q3 charge here. Suppose I'm just giving an example, and this distance suppose is R1, this distance suppose is R2, and this distance suppose is R3. Done. So suppose somebody is now telling me कि calculate force on Q1. So on Q1, force will get applied by two charges, that is Q2 and Q3. Done. So force acting on Q1 because of Q2. What is superposition principle? That I am explaining. Force acting on Q1 because of Q2 will not get affected by Q3 present. ठीक है? So when we will write force acting between Q1 and Q2, we will simply forget Q3 because Q3 is not going to affect force acting between 1 and 2. ठीक है? तो यहाँ पे आप देख लो फोर्स एक्टिंग ऑन वन, मैग्नीट्यूड में अभी बस लिख रही हूँ, बिकॉज ऑफ टू कैन बी रिटन एज व्हाट, अगेन सेम एज K Q1 Q2 by R1 का स्क्वायर. दिस Q3 is not going to affect this formula or direction in any way. ठीक है? Again Q1 Q2 are having same charges, so Q2 will repel Q1. It means on it force at F12 direction will be this. So both magnitude and direction of force acting on one because of two will not get affected by Q3 present. That is principle of superposition. So this is very simple. So just calculate force like you have been calculating before. ठीक है? जैसे आप पहले calculate करते आए हो वैसे ही करना है, कुछ भी difference नहीं. Only thing is कि you have to write like so directions very proper. तो चलो मैं यहाँ करके दिखाती हूँ एक. तो यहाँ पे आप देख लो, सपोज दिस इज अ Q1 चार्ज हियर एंड दिस इज अ Q2 चार्ज एंड दिस इज अ Q3 चार्ज. माय टास्क इज, व्हाट इज माय टास्क? माय टास्क इज टू कैलकुलेट फोर्स ऑन Q1 because of Q2 and Q3. So I have to calculate force on 1. Done. So force on 1 will be because of 2, because of 3. So I will write force on 1 because of 2 plus force on 1 because of 3. ठीक है? अब आप individually you just write F12. So F12 if you're going to write, it will look like what? First let's see the direction. So Q1 Q2 Q3 all are positive charges. So Q2 will repel Q1. repel का मतलब ये इसको खुद से दूर भेजेगा, है ना? So if Q2 is going to repel Q1, यानी कि force on 1 because of 2 will act in this direction. This is the direction of what? F12. ठीक है? And this distance, if you say कि this is R1, this is R2, and if you're going to calculate it vectorially, that you can do. तो यहाँ पे this distance will come as R12. Again, this is a vector thing. I have given you instruction the previous class कि please do revise vector. क्योंकि I don't need to discuss vector here much now. You already know about such things. So directly I'm writing here R12. फिर भी किसी को doubt हो तो please you can write here in the chat box. You can raise your hand and all. ठीक है? आप जैसे भी पूछना चाहो you can ask. I'm open to questions. ठीक है? But I'm assuming you can understand here कि R12 is this. If you're not able to get, you can ask. ठीक है? तो यहाँ पे अब आप देखो Q1. Now let's calculate F13 direction wise. So again Q1 and Q3 are positive charge both. So Q3 will repel Q1. So again force acting on Q1 because of Q3 will be in this direction. So this is this, if this is R3, so this length is nothing but R1. ठीक है, R1 minus R3 will be this. ठीक है, now we can clearly write it magnitude wise. So this is what, this was Q1, this was Q2, this was Q3, this is R1, this is R2, this is R3. So F1 will be equal to F12. F12 को अब मैं लिखती हूँ यहाँ पे K Q1 Q2 by R12 का स्क्वायर into R12 वेक्टर के डायरेक्शन में यूनिट वेक्टर है ना. This is your R12, right? Now what is your what is the force if F13, if you're going to write, so K Q1 Q3 by R13 vector का मॉड्यूलस का स्क्वायर into R13 unit vector. Okay, so this is this. Now we have to like force acting on one each. What if I can parallelly translate vector, right? So I'm going to just write it here. F12 is this, F13 is this, F12 is this, F13 is this. So if angle between these two vectors is known, we can calculate here F1 by the formula of vectors. दो वेक्टर को हम कैसे ऐड करते हैं? So formula will look like what? F1 का magnitude will look like what? F12 का स्क्वायर वेक्टर का स्क्वायर प्लस F13 मॉड्यूलस का स्क्वायर प्लस क्या लिखोगे? 2 इंटू दोनों फोर्सेस को लिखोगे आप F12 का मैग्नीट्यूड इंटू F13 का मैग्नीट्यूड इंटू क्या लिखोगे? cos थीटा, है ना? If this angle is theta. So this is the formula, you all know. If A and B are the vector and theta is the angle between them, then A plus B is equal to क्या होता था? That is equal to nothing but root over A square plus B square plus 2AB cos theta. So same thing you have to apply here. ठीक है? Clear है सबको? JNB खमम क्या है? बहुत late you people have joined. What's the reason? Please यार, don't just come, see and go. है ना? एक कोई ट्रेलर नहीं है जिसको थोड़ी देर देखा फिर चले गए, है ना? ट्रेलर थोड़ी देर में इंटरेस्टिंग लगता है, फिर समझ में भी आ जाता है, but this is totally a different phenomena. This is your class 12 physics class, है ना? तो चलेगा नहीं ऐसा. Please don't take it otherwise. It's my very humble request कि please come on time, है ना? This way we both will enjoy, है ना? तो चलो, superposition principle again. If I want to make it more clear to you, तो चलो एक example ले लेते हैं. Suppose कर लो, this is a square, this is A, this is A, this is A, this is A. Suppose I have kept here Q charge, Q and Q. If I have to calculate force on this Q charge, this one, so what will be the value of force here? तो सबसे पहले डायरेक्शन वाइज लिख लो. this charge will apply force on this Q. In which direction? It will repel. So in this direction. This charge will also apply force on this Q. In which direction? It will also repel. So in this direction. And क्योंकि direction of force will be along the line joining two forces ना, and this Q charge will also apply force on this, and its direction of force will be in this direction, है ना? So this is F1, this is F2, this is F3. So total force acting on this Q charge will be what? Sum of these three. We can easily add these three if we know vector, है ना? So but superposition principle is nothing but this. Okay? I hope it is clear. Now this is the question. It came in IIT or yes, long back, very long back, but still, let's solve it. है ना? So I am giving you some 1.5 minutes. Read the question, or 2 minutes you take. Read the question and do it. And let me know the answer. ठीक है? तो आप करके बताओ. Again, it came in IIT doesn't mean it's tough. बहुत ही easy है. CBSE level का question है. ठीक है? So आप सब करो. And let me know if you have any doubt. If you're getting stuck in understanding the question or anything, just let me know. Huh? Please, if you're getting answer, please do reply in the chat box. ठीक है? If possible. क्योंकि conversations will keep on happening. JND bicep. Please do consider once again. Just I will give you one hint. There is no charge on this corner. है ना? इस कॉर्नर पे कोई चार्ज नहीं है. There are charges kept on 5 corners only. है ना? So see the things carefully. JNB Rajkot. Yes, very good. सही है, सही है, सही है. Come on, everyone. Come on. You all can do it very easy. Come on. क्या हुआ? सभी इतने शांत क्यों हो? Come on, do it. Are you all waiting for me to do? उससे पहले तुम्हें कोशिश करना है ना. Then only you will learn. You know, in physics, it's very important that you try every question. If you're not trying, and after that, even if I'm explaining very well, it won't benefit you to that level. For that, you need to try before I solve any question in there. है ना? So, जब भी मैं बोलूं do the question, please don't take the benefit of कि nobody is looking over you. Please do it for yourself. है ना? करना बहुत जरूरी है. तो चलो मैं अब करती हूँ. यहाँ पे -q charge रखा हुआ है. What the question is, 5 point charges are there, each of value plus q coulomb are placed on 5 vertices of a regular hexagon of side L. So regular means regular hexagon का मतलब हर side equal होगा. So this is L, 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 L and L. है ना? You know, it's very important now कि we are very much aware of geometries. Geometry को जानना बहुत ज्यादा जरूरी है. JNV Veer Somnath, क्या है यार? You are joining half an hour almost ahead. Why so much late? Please do attend on time. Otherwise, what you people are doing now? You people are simply joining, doing it as a taking it as a formality, and then going away again. So it's not going to be of any use. Please, if you want to make use of this, you must join on time and you must stay throughout. है ना? ये सब आपके लिए ही है. Please take benefit of it. है ना? तो यहाँ पे देखो रेगुलर हेक्सागन है. एंड आई वाज सेइंग कि फिजिक्स में बहुत जरूरी है कि यू हैव अ नॉलेज ऑफ ज्योमेट्री आल्सो. लाइक दिस इज अ रेगुलर हेक्सागन. इट मींस L, L, L. Also, if you will analyze it more, this side also will become L, L, and all angle will become what? 60 degrees. So this knowledge of geometry is very much important. Here it is not required. I just discussed. तो अब यहाँ पे देखो forces कैसे होंगे. Just let's see how force will act on this minus q charge. So this plus q charge will apply force on this minus q charge, and force acting between these two will be what? Attractive force. So this q will attract minus q. Attract means it will pull it towards itself. So force direction will be this. This q charge will also attract because this is negative, this is positive. We are calculating force on minus q. ये दिया हुआ है ना question में. So again, force acting will be in this direction. Similarly, because of this charge, force will be in this direction. Because of this direction, and because of this direction. Again, you can see here the distance between any pair of charges. मतलब this minus q and q, this minus q and q, is same now. This is L, this is L, this is also L, this is L, this is L. So distance is same also. Yes, JNB Khammam. Very good. Very good, very good. तो यहाँ पे फोर्सेस क्या होंगे, ये फोर्स और ये फोर्स कैंसिल हो गया, इक्वल एंड ऑपोजिट. ये फोर्स और ये फोर्स कैंसिल हो गया, इक्वल एंड ऑपोजिट. Only one force will remain, and that is your this one. No, so its value will be how much? KQ by L ka square, and direction will be in this sense, in this. Okay, so this is done now. Yes, is it done? Any doubt? Anyone? Anyone? Any doubt? चलो ठीक है, अगर डाउट नहीं है तो दिस इज द आंसर. And let's move ahead with another topic. So we are going to now read electric field and its properties, equilibrium of charge system, electric flux. Okay. So basically in this class we will discuss this one. Okay. Largely we will discuss this one, and after that this. So chalo karte hain. What is electric field? So like suppose I am taking a charge here Q. Okay, so I have fixed it, suppose somehow, and this circle I have made. So I am saying कि whatever is beyond this circle is at infinity. तो suppose कर लो यहाँ पे कोई आदमी खड़ा है, तो this इस circle का मतलब ये है कि distance between this charge and this person is infinite. So whatever is outside the circle, I am telling कि that is at infinite distance. ठीक है, that is my take here. तो इसलिए मैंने ये सर्कल ड्रॉ किया है. अब क्या होगा, यहाँ पे मैंने चार्ज Q रखा, सपोज कैपिटल Q. नाउ व्हाट आई एम डूइंग नाउ, सपोज दिस पर्सन इज हैविंग चार्ज Q ऑन हिज और हर हेड. इसके सर पे कितना चार्ज है? Q चार्ज. सो दिस पर्सन एंड दिस चार्ज आर एट इनफिनिट सेपरेशन. सो डेफिनेटली व्हाट विल हैपन, इफ सेपरेशन इज इनफिनिट, इट मींस फोर्स अगर मैं निकालूं तो Q by infinity का square है ना. So it will come out to 0. No force. It means this charge and this charge is not interacting है ना. So there is no interaction. Now what I am doing, I am bringing this person. This person is walking and coming closer to this charge capital Q. So this person has reached, suppose here. So charge Q has came here. Now this is at some finite separation R, so force will act. Now the question is, scientists started thinking कि what is there at this point? इस point पे है क्या? ऐसा क्या है कि यहाँ पे जब भी कोई charge आ रहा है तो that charge is experiencing force. जैसे here, if there is nothing at this point, no force is acting, but the moment we drop here a charge, it will start experiencing force very instantly, है ना. So scientists said कि because of this charge, capital Q charge, in its space there is something, and that something is interacting with any external charge coming and applying force. ठीक है, और उसी something को उन्होंने क्या बुलाया? Electric field. So scientists started telling कि if there is a charge, so in its vicinity, in its surrounding, its effect will be there. And that effect physically they showed with the help of electric field. तो electric field एक hypothetical concept है. हम इसको इसलिए पढ़ते हैं to make it easy to understand कि कोई भी charge पे force क्यों लग रहा है, किस direction में लगेगा, कैसे लगेगा. ठीक है. So electric field done. What is electric field again? So this is nothing but a space around the charge. This is space around the charge in which influence of this charge will be felt. Done. And that influence is being felt because of what? That is called electric field. Done. I said कि whatever charge you bring here, suppose you brought here t equal to 0 time पे आपने यहाँ पे charge लाया. So after some nanoseconds or very less time, this charge will start experiencing force. So this electric field here get set up very instantly, है ना. Then चलो बाद में और भी explain करेंगे, but अभी के लिए इतना रखते हैं. Now how to draw the electric field? Then so let's now draw the electric field. Here I have taken two charges, positive and negative. One important thing is here, कि इन दोनों चार्ज के बीच का जो यहाँ पे मैंने सेपरेशन दिया है ना, r इक्वल टू इन्फिनिटी दिया है, ठीक है, दैट इज वेरी इंपॉर्टेंट. So it means this positive charge and this negative charge are not interacting. They are not in the surrounding of each other. They are at infinite separation. That is first thing. तो चलो अब देखते हैं कि इलेक्ट्रिक फील्ड को हम ड्रॉ कैसे करते हैं. So how we draw it? Two rules. If we have a positive charge, then electric field will come out from it. तो यहाँ से देखो ये पॉजिटिव चार्ज है, यहाँ से इलेक्ट्रिक फील्ड को पहले स्ट्रेट लाइन से ड्रॉ करते हैं. तो ये स्ट्रेट लाइन इलेक्ट्रिक फील्ड से क्या हो रहा है, निकल के वापस आ रहा है. अगेन दिस आर नॉट दिस, ये ब्रेक की तरह दिख रहा है बट ये कंटिन्यूअस होगा, ठीक है, ये ब्रेक की तरह से दिखाया गया है बट इट विल बी व्हाट, कंटिन्यूअस, ठीक है. ये कैसा होगा, कंटिन्यूअस, नो ब्रेक्स, कंटिन्यूअस, राइट. So from positive charge, electric field emanate, it comes out, right? For negative charge, what's the rule? Electric field will end at negative charge. Electric field will end at negative charge. Again, electric field lines are continuous line. यहाँ पे इस तरह से दिखाया गया है, continuity ही दिखाया गया है, लेकिन अगर confusion हो तो मैं इसलिए ऐसे draw कर दे रही हूँ, ठीक है. So these are continuous lines. So on negative charge, what will happen? Electric field line will end at negative charge and electric field line will comes out of positive charge. First thing. Second thing, suppose कर लो यहाँ पे plus Q charge was there, plus Q charge was this and this was minus Q. Now what I'm doing, I am taking plus 2Q charge. So if I am taking plus 2Q charge, simply I have doubled the charge. How the electric field lines will look now? So for this plus charge, how many electric field lines are coming? 1, 2, 3, 4, 5, 6, 7 और 8 है ना. 8 field lines I have shown here. 8 field lines I have shown here. Now, if charge is double, more field lines will come out of it. If it is getting double, then we will draw here 16 electric field lines coming out. ठीक है. So conclusion is what? Conclusion is that if charge magnitude is more number of field lines will come out of it. It means कि आप यहाँ पे ध्यान से देखो first case में, this is the first case. So here electric field lines are not more crowded as that of here. So as the magnitude of charge increases, crowding of electric field lines increases. That is, density of electric field lines increases. ठीक है. तो higher the value of charge, more crowded will be the lines. ठीक है. एक चीज और है यहाँ पे जो आप ध्यान से देखो, जैसे मैंने सपोज करो प्लस 2Q के लिए आई हैव ड्रॉन इट हियर, ठीक है, मैंने इस तरह से ड्रॉ किया. देन तो जस्ट वन थिंग आई वांट टू शो हियर. अब आप यहाँ पे ध्यान से देखो, आई एम ड्रॉइंग अ सरफेस. सपोज मैंने कुछ ऐसा सरफेस ड्रॉ किया, ठीक है, ऐसा सरफेस. And if I am going to take this surface away from plus 2, so same surface I am taking it away. So as I will take it away, what is happening here? Clearly आपको दिख रहा है, जैसे इस surface से पहले कितने field lines cross कर रहे थे? 4 है ना. जैसे जैसे हम दूर जा रहे हैं, less number of field lines are crossing through this surface. It means if less number of field lines are crossing, it means the charge density, field density gradually as we move away from the charge is decreasing. तो field line का density decrease कर रहा है, मतलब value भी क्या होगा, decrease होगा. समझ रहे हो? So its value will also decrease. Now how to calculate its value? So electric field lines value is nothing but force acting per unit charge. This is nothing but this. तो इसको मैं simply ऐसे लिख देती हूँ. If two charges are like k q by r square, so suppose कर लो कि यहाँ पे मेरे पास एक plus q charge है. This is a fixed charge and there is a small charge q. इसको generally test charge बोलते हैं, क्योंकि हम इसको यहाँ पे ला रहे to test की what's the value of electric field is here. So this is the test charge. Now what is the force acting on this test charge? So that will be equal to k q by r square. So force acting per unit test charge will be how much? This. So what will be the value of electric field at this point because of this charge? कितना होगा? K Q by R. Done. So this is how we calculate the value of electric. So as we will move away, as we are moving away, what is happening? R value is what? R value is increasing. So if R is increasing, electric field will decrease. So value wise it will decrease. That is why field lines densities are also decreasing. Done. So what are the conclusion? Conclusion are very clear कि electric field line will come out of positive charge. ठीक है, वो positive charge से आएगा. It will end at negative charge. दूसरा, if magnitude of charge is more number of field lines will come out of it. Third, field lines will be more crowded near the charge, and as we will move away from the charge, crowding of field lines will decrease because value of electric field is decreased. ठीक है, so these are the things. अब यहाँ पे देखो प्लस क्यू चार्ज है माइनस क्यू चार्ज, इसका इलेक्ट्रिक फील्ड बनाना है. तो सभी लोग कॉपी पे 1 मिनट के लिए ट्राई करो, कैसे बनाओगे. अगेन दे आर नॉट एट इन्फिनिट सेपरेशन, देयर सेपरेशन इज फाइनाइट. ठीक है, सो इनके बीच के डिस्टेंस को फाइनाइट रखो, आर है सपोज, सो दे विल इंटरैक्ट. नाउ ड्रॉ द इलेक्ट्रिक फील्ड लाइंस, एवरीवन डू इट. चेनबी नॉर्थ त्रिपुरा, क्या हो गया भाई, इतने लेट क्या कर रहे हो, ऐसे क्लास ज्वाइन करोगे. Please be on time, everyone. It's my request. Because I really want to see you somewhere after 1 year. And for that, I need your loyalty, I need your dedication, I need your punctuality, right? And I promise all of this from my side. चलो, बन रहा है सबके कॉपी में. Please, no one will sit. ऐसा नहीं है कि question timing is your time of relaxation. No, draw the things on your copy. तो आप लोग जल्दी से बनाओ. What you will do, from positive charge, electric field lines will come out. Again, field lines ऐसे बना रहे हैं again, and the electric field lines will end at negative charge. So these are ending at negative charge, है ना. So if positive and negative charge are very close or they are at finite separation, electric field lines coming from positive charge will end at negative charge also. So this also might happen, ना, ऐसे, है ना. Why this line is not straight? क्योंकि यहाँ पे दोनों के बीच में इंटरैक्शन हो रहा है ना, because of this interaction this is bent. क्योंकि अगर मैं इसको हाई में एक्सप्लेन करूं, जैसे अभी मैंने सिर्फ प्लस क्यू के लिए बनाया था, तो फील्ड लाइन स्ट्रेट बनाया था ना, याद है तुम लोगों को. Why straight line? Why not curved here? क्योंकि देखो यहाँ पे this electric field line, this सपोज करो मैं 2 इलेक्ट्रिक फील्ड लाइन पे फोकस करती हूँ, ये और ये. So both are coming from the positive charge, है ना, both are coming from positive charge. So they both will repel each other. Done. So they will be at maximum separation. अगर मैं explain करने का एक तरीका बताऊं, so again we don't need to go there. But यहाँ पे अगर तुम जानना चाहते हो कि why it is bent, तो यहाँ पे plus q और minus q में क्या हो रहा है, attractive force लग रहा है. So if electric lines are like this electric field is getting attracted by this minus q, so it is bending towards minus q. ठीक है, simple explanation. Let's not complicate. ठीक है, so this is simple. सबका आ गया होगा I guess. So it will look something like this, है ना, ये कुछ ऐसा दिखेगा. Done. बाद में हम पढ़ेंगे कि if this r is very very small, it's very small, then this is called dipole, है ना. तो dipole बाद में पढ़ेंगे हम लोग. अब यहाँ पे देखो एक प्लस क्यू और प्लस क्यू लिया है. Draw the electric field lines for this too. Now again do it fast. Again I'm giving you some 30 seconds only this time. चलो जल्दी से बताओ. Sorry, बता तो नहीं सकते, but everyone be honest and draw it in your copies. ठीक है. What will happen if plus q is all alone? Their electric field lines will be like this, है ना, कुछ ऐसा होगा. Suppose कर लो again these two are at finite separation. ठीक है, तो 2 plus q चार्ज जब अलग अलग है, infinite separation पे है, तो हमारा इलेक्ट्रिक फील्ड लाइंस कुछ ऐसा दिखेगा अगर इनफाइनाइट सेपरेशन पे है तो. If separation is finite, what will happen? This charge Q will repel this charge Q. So their electric field lines will also repel each other. So the line that is trying to go towards plus Q will get repelled. So ये वाला line ऐसा नहीं दिखेगा अगर ये दोनों finite separation पे है तो ये कुछ ऐसे repel हो जाएगा, दूर जाएगा, है ना? So electric field lines will look like this. देखो इस space में कोई electric field line नहीं है. क्यों? Because this plus Q and this plus Q are repelling each other, so their electric field lines will also repel each other, and that is why they are going on like this. Okay, done. Okay, so what is the conclusion? Electric field exists for all charges and extend up to infinity. You know, field lines will be continuous. Electric fields never intersect with each other. Again, this is point. Let me discuss here. Suppose कर लो यहाँ से electric field lines ऐसे निकला, and second line I'm making like this. So is this a correct diagram? No, it's not correct. Why? क्योंकि अगर electric field lines जैसे देख लो हमारा जैसे previous example पे चलते, यहाँ पे देख लो इस electric field lines की अगर मैं बात करूँ तो suppose someone is asking me what is the direction of electric field at this point. So how we will find out the direction of electric field from this given diagram at this point? So simple rule is draw the tangent. So if I am drawing here the tangent, this is, and इस tangent का direction हम दोनों तरफ दे सकते हैं, downward, upward. लेकिन electric field line is in this direction ना, so tangent direction will be this. So at this point, direction of electric field is in this direction. ठीक है? Now suppose I'm taking a case where electric field lines are intersecting like this. So at this point, electric field one is in this direction and another tangent can be drawn in this direction. So there are two directions of electric field at a single point. It is not possible. जैसे एक point पे अगर ऐसे ऐसे दो direction आ रहा है, ultimately they will add up and become one ना. So direction of electric field should be one only. And that is why they will never intersect each other. If two loops are intersecting, so at this point we can draw two tangents now. So two direction of electric field it will show up, and that's not true. Again, third point, number of field line is proportional to the magnitude of charge. Charge के magnitude से number of field lines क्या होगा? Proportional होगा. This thing I have explained already. So चलो fast tell me, only take some less than 1 minute. Please. This question is very easy again. You just have to tell me which option is correct. चलो फास्ट सब लोग चैट बॉक्स में एक्टिव हो जाओ. देखो हार्ड वर्क ना हमें करना पड़ता है. मैं जानती हूँ तुम लोगों का खेलने का टाइम नहीं होता, ये नहीं होता, वो नहीं होता, बट something we need to sacrifice to get something, है ना? We can't have everything ना. नहीं हो सकता. पेट भी भरना है, खाना भी बचाना है, कैसे होगा? नहीं होगा ना. If you are filling your stomach, your plate will get empty ना. But if you want to keep your plate also full, your stomach also full, how that will happen? Not possible. So do hard work. Hard work मतलब softly करना है. Hard ऐसा नहीं कि तुम्हारे दिमाग पे hard हो जाएगा, है ना? चलो fast, let me know the answer. Yes, I got one, I guess. JNV Hyderabad, yes, very good. North Tripura, very good. Others, please. Somnath, Ahmednagar, Simoga. I got from Hyderabad region. Yes. Okay, others, please. Please, please, please. This time I want from Simoga and North Tripura. Come forward, Somnath. Somnath is famous for one temple now. काश ऐसा होता कि मैं आंखें बंद करती and I could reach there in your class. कितना अच्छा होता ना ये पावर होता तो. सोमनाथ, yes, see. Very good. चलो मैंने तो अब ऑप्शन भी बोल दिया. गॉड. चलो डन है. सो व्हाट विल बी द करेक्ट ऑप्शन हियर? करेक्ट ऑप्शन विल बी सी. क्यों? यहाँ पे देखो Q1 Q2. पहली चीज, इलेक्ट्रिक फील्ड लाइन इज एंडिंग एट दिस टू चार्ज. यहाँ से भी इलेक्ट्रिक फील्ड लाइन Q1 पे सारे इलेक्ट्रिक फील्ड लाइन एंड हो रहे हैं, तो Q1 नेगेटिव होगा. Q2 पे भी सारे फील्ड लाइंस एंड हो रहे हैं, तो Q2 भी क्या होगा? नेगेटिव होगा. बोथ आर नेगेटिव. रिपल्सन भी है दोनों में. देखो दोनों का फील्ड लाइन एक दूसरे से काफी इस स्पेस से में आ नहीं रहा, दूर दूर है. डन. सो दैट्स व्हाई दे आर ऑफ सेम नेचर एंड दे आर नेगेटिव बिकॉज फील्ड लाइंस आर एंडिंग. ठीक है, चलो ये क्वेश्चन जल्दी से करके बताओ. आई एम गिविंग यू सम 2 मिनट. देखो, I am trying to manage between theory and question giving also in this 50 minutes because I want you to solve question also. तो 2 मिनट में फटाफट करके दिखाओ जल्दी से. If you get doubt, you can ask me through the chat section. And don't be in hurry. Read question properly. ठीक है? I've given you 2 minutes. 2 minutes is very much enough. Read question properly, draw the diagram if needed, and then go to the solution. मतलब go to solving. तो क्वेश्चन सही से पढ़ना बहुत जरूरी होता है. So do read carefully. हाँ, जेनवी तापी. हाँ, सारा रामायण खत्म तब आ गए हम. क्या समझ में आएगा? राम was villain और रावण was villain नहीं समझ में आएगा. दोनों को ही विलेन बता दोगे. Hyderabad. No. Think more carefully. Proton है, एक इलेक्ट्रॉन है. There is difference in their masses, right? मैंने very first class में very first page I have showed you कि what? I have shown you what? Electron has a mass of 9.31 into 10 to the power minus 31. And proton has a mass of 1.67 into 10 to the power minus 27. I said you, proton is some 10 to the power 4 times approximately heavier than that of what? Electron. Masses are different. Consider it, please. Okay. North Tripura. Yes, very good. Very good. So, North, like if I'm getting answer from one GenV, doesn't mean all the students of that GenV have solved it. So, अगर एक का हो जाए तो सारे बैठ मत जाना. Everyone, please solve it. ठीक है? Somnath. Okay. Yes, very good. Still, same applies to every GenV. Each one of you has to solve it. So do solve it. ठीक है? Ahmednagar. Yes. Very good. Okay, very good. JNB गोंदिया. वाह, क्या कमाल है यार. अभी आ रहे हो. This is just a massive. क्या कर रहे हो तुम लोग? क्यों नहीं क्लास टाइम पे आ रहे हो? सो रहे हो. सोने से क्या होगा? This is not going to help in your exams. And in the time of exam, you people will simply like put your hands on your head and feel like कि क्या हो गया? Give your time now so that you don't regret later. It's very important. Please, your next class say I want to see all 12 of, or 11 or 10 of JNBs whoever is here on time. Please do maintain that. तो चलो मैं इस क्वेश्चन को समझाती हूँ. So what the question is here? So the question is, an electron falls from rest through a vertical distance h in a uniform and vertically upward directed electric field. So electric field is directed in this sense, and there is no talk of gravity here. So simply we have to neglect the gravity. है ना? कोई बात ही नहीं हुई उसकी. तो तो ग्रेविटेशनल फोर्स को यहाँ पे हमें क्या करना है, नेग्लेक्ट करना। ऐसे भी ग्रेविटेशनल फोर्स और इलेक्ट्रिक फोर्स को अगर आप कंपेयर करो for 2 point masses, then electric force will be more stronger, far more stronger than that of gravitational force. So we can also neglect in that sense also. ठीक है, so we have to neglect here the gravity. तो चलो अब क्या है, electric field is directed upward. What is happening? Electron is falling in the downward direction through height h. So electron is coming down through height h, and electric field is directed in the upward sense. Now the direction of electric field is now reversed, keeping its magnitude the same. Magnitude क्या है, same है. A proton is allowed to fall from rest in it through the vertical distance h. So proton को fall करने के लिए दिया जा रहा है electric field का direction. Second case कुछ ऐसा है, electric field direction has been reversed. So now it is like this. Magnitude is same still. ठीक है, and proton is falling now downward again through the same height h. So we have to compare time taken by electron and proton to come down. ठीक है, so suppose electron is taking t amount of time and proton is taking pt amount of time. Let's calculate it for electron only. So if electric field is in upward direction, force acting on electron will be in which direction? तो मैं इस क्वेश्चन के थ्रू यही डिस्कस करना चाहती थी बेसिकली कि कैसे आइडेंटिफाई करेंगे। तो चलो यहाँ पे मैंने एक सिंपल सा चीज दिया, सपोज प्लस क्यू चार्ज है, इलेक्ट्रिक फील्ड इज इन दिस सेंस, ठीक है, तो ये स्ट्रेट होगा, ठीक है, तो इलेक्ट्रिक फील्ड इज समथिंग लाइक दिस। डन, सपोज कर लो यहाँ पे मैंने एक इलेक्ट्रॉन को रखा, डन, सो इलेक्ट्रॉन मीन्स नेगेटिवली चार्ज, दिस इज अ प्लस क्यू चार्ज. Now force acting on this electron will be in which direction? You just think for some seconds. इस direction में इस electron पे force लगेगा because of this plus q charge. One is plus q charge, another is negative charge. Attractive force will act. So this plus q will attract electron. ठीक है? So attract means it will apply force in this direction. तो आप यहाँ पे देखो इस point पे electric field is in this direction and force acting on electron is in this direction. So just keep it in your head for the whole class 12. If negative charge is there in an if electric field is like this and if negative charge is there, so electric, because of this electric field, force acting on negative charge will be in which direction? Opposite to the direction of electric field. ठीक है, that is explained here. Done. So यहाँ पे देखो ये इलेक्ट्रॉन डाउनवर्ड फॉल कर रहा है, इस पे इलेक्ट्रिक फोर्स किधर लगेगा? ऑपोजिट टू द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड. सो फोर्स विल एक्ट ऑन दिस इलेक्ट्रॉन इन द डाउनवर्ड डायरेक्शन. हाउ मच फोर्स? तो मैंने अभी बताया था, जैसे इलेक्ट्रिक फील्ड का फॉर्मूला क्या था? व्हाट वाज द फॉर्मूला? If there is a q charge at r distance, electric field formula was what? kq by r square. Done. And if we are so this is the electric field, and if we are keeping here charge q, so force acting on this charge q हम कैसे लिखते हैं? kq by r square. So this is nothing but electric field into charge, है ना? So force acting, if electric field is given, can be written as magnitude, can be written as charge into electric. So force acting on electron will be how much? E charge into electric field. Done. This is force. Acceleration of electron will be how much? F by m. So this is E by that is mass. So this is the acceleration. By how much distance it is coming down? H. Initial velocity of electron is what? It is released from rest now. So initial velocity 0 है. So time taken. Second law of motion we can apply, क्योंकि यहाँ पे acceleration is constant. We can apply laws of motion. तो आप लिख लो S equal to ut plus half at square. So initial velocity is what? 0. By how much distance it is coming down? H. So downward direction को मैं positive ले रही हूँ. So H equal to half. Acceleration क्या हो गया? E by m t square. So यहाँ से अगर तुम time निकालोगे, if you are going to write the value of time from here, तो t का value क्या हो जाएगा? 2mh by how much? E. का रूट ओवर. सो टाइम इज डायरेक्टली प्रोपोर्शनल टू मास, है ना, रूट ओवर मास. सो जिसका मास ज्यादा होगा वो ज्यादा टाइम लेगा, जिसका मास कम होगा वो कम टाइम लेगा. सो electron is going to take less amount of charge. So many of you answered it. Thank you so much. Sorry, time is running up actually. So yes, everyone take care of yourself. Do revise through things. Tomorrow we will cover more things, and then I will be giving you some 1 or 2 homeworks also. Done. आज के लिए you just go and revise. Done, so that in the next class you will be more comfortable with things. ठीक है, bye bye, take care, relax. चलो, और कल के क्लास में